Determining context classification, irregular block structures. This webinar will address issues with how you measure block perimeter and block length in locations where the block structure is irregular or unusual. We'll talk about some of the common challenges related to how do you define a block in conditions like this, how to apply the 2,000-foot rule for the block perimeter when there's not a network in place, and how to address frontage roads. Just to review, for context classification, where we're trying to determine block length and perimeter, we start by looking at each individual segment of a block. Let's say this blue road going through the middle of the drawing here is our FDOT roadway. We would measure the distance between each of the intersections to get the block length, and then we would add up each of those individual blocks and average them to get an average block length. Similarly, when we're trying to get the perimeter, we would measure the perimeter of one of the blocks like this, and then we measure each of the other blocks and get a collection of perimeters there. You would add all those up and average those, and you get an average perimeter. And that's pretty straightforward in conditions where you have a well-defined block structure, such as the one that is shown here. And this is also a pretty common block structure that you would see in your C6, C5, and C4 conditions. When you get out into suburban and rural conditions, however, this block structure may not be as apparent. So here we have an example of a situation where the block structure may not be quite as apparent. In this kind of a situation, we need to understand that the blocks are defined, first of all, by the public streets. So driveways do not count for our purposes here as creating an intersection for the purpose of a block, determine a block length or a perimeter. So we'd be looking, for instance, that just at these public streets that you have here, each of these public streets is going to create a segment of a block. But the driveway that you see in the middle here, that's a private driveway that just is serving a shopping center or an apartment building, that does not count as part of your block system. So when we go through and begin to add up our block lengths, we'll add up all the ones between the public streets, but we'll ignore the lengths that connect to driveways. And of course, you would do a context classification looking at each side of the road individually. So we do the one side, in this case the top side first, and the lower side we come back and do it the same way. And again, we ignore the length that has the driveway in it because that's not a public street. So we're only looking at the blocks that connect the public streets. So then for trying to determine the perimeter in a situation like this, if you don't have a consistent series of links that create a grid network structure, what you can do as recommended is to create a cordon line 2,000 feet away from your roadway. In this situation, let's say our state roadway is going through the middle of the drawing here, the middle of the photograph. So we would measure out 2,000 feet from that and draw on a cordon line. That's our 2,000-foot boundary. So, and the 2,000 foot was established as a way to give all communities a chance to show that they had some block structure if they had any, and we couldn't make that number infinite. We wanted to make it long enough to account for the fact that we do have odd-shaped blocks in some places in Florida, and those those count too. But at the same time, we had to find a measurement that would capture most of the urban places in Florida, but wouldn't send us out into infinity looking for block structures that didn't exist in rural areas. So that's where this 2,000 foot came from. So the way we would do this in practice, you start to draw your perimeter. So in this situation, you see I have a road over here. It's coming down on the red line, so I follow that road back. Well, I didn't get to another intersecting street before I got to my cordon line, so I'm going to use that 2,000-foot cordon line as the back end of my block. So I follow that along until I come to another roadway, and then I follow that roadway back into my main road, and that's my first block. For my next two blocks, they're pretty straightforward because they actually are very small blocks that have a grid system associated with them. So those are small blocks there. But then when I look at this next one, again, I have a situation where the roadway does not complete a block before it gets to the 2,000-foot cordon. So I treat the cordon as the back end of my block, draw along there, and then I follow until I come to another road that does connect in, and I follow that road around, and that gives me that block there. So I basically created a block where none existed before, a block structure, using this 2,000 foot cordon. So you would repeat that exercise with each of your other segments, noting that in some cases this is going to give you some rather strange looking blocks, and if that's the case, then that's the case. Go ahead and draw them out and calculate the perimeter of those. That's very easy to do in Google Earth or using GIS to calculate those perimeters, even if the shape is rather odd. So go ahead and finish and get all your blocks. So once you do that, then you can actually get average all those perimeters, and you get an average block perimeter based on the block structure that you have there in this 2,000 foot cordon. So when we go back and look at intersection density, we do a similar thing. We look at the area of our blocks that we're working with, and we begin counting the intersections within there. And these are intersections, again, of public roads with other public roads. We're not counting driveways. So we count all the ones that are inside. Also make sure you include any intersections that are going along your boundaries of your blocks. So if I have an edge of my perimeter that's also a street, and there are intersections along that street, I want to count those as well. But I don't count locations where my perimeter is using the back wall of the cordon as part of the block structure. So that's not those corners there where the road is basically extending out into infinity and it crosses our 2,000 foot cordon. We don't count that as an intersection for the purposes of calculating intersection density. So we leave those alone. But then you measure your total perimeter area that you have to get your total square miles and divide that by the number of intersections. You get an intersection density per square mile, and that can be plugged into the matrix to tell you what context classification you're looking at based on that particular parameter. Another question that has arisen from time to time is, well, if you have a situation where we have frontage roads, how does that work for calculating block structure? Where do I calculate that from? So here we have a state road in the middle, and then along each side of it we have a system of frontage roads. And this is very popular for access management as a way to preserve the capacity on the mainline system. As you can see then, we have local streets that come and connect into these access roads at certain locations. Some of these intersections go all the way and connect all the way into the state road. Some of them do not. So if you look at this one, for instance, this is a place where the block structure connects into the access road, but it does not connect into the state road. That's okay. What you should do is count anything that connects into the access lane that's a public street. Go ahead and count that as part of your block structure. So we'll go ahead and count that one, even though it does not connect into the state roadway. It does connect to the access road, which is part of the transportation system. As long as it's a public street, we'll count that as a part of our block structure. So then we would come back and when we measure our block lengths, we would measure them based on those connection distances there, based on where those public streets intersect with my access road. So there it is on the north side, and then we do the same thing on the south side. Then as I'm determining my perimeters, I do the same thing. I go down to the access road to determine that perimeter, and I'm not super worried about whether or not that actually connects all the way into the state road or not. As long as it connects to the access road, that's okay, as long as it's a public street. And you just repeat that exercise for each of these, and that gives you your block perimeters. So those aren't too complicated as long as you understand that you're looking at any public road that connects to the access lane. It does not have to connect to the state roadway itself. We also have situations where the block structure can get really fairly convoluted, and if you have places that have been highly urbanized and maybe urbanized by, say, a number of different developers over the years, each with their own kind of plan for how they were doing things, each maybe with a different product that they were trying to bring to market, a different way of selling that product, you can end up with a variety of structures. This is great from the perspective of providing a lot of variety in the market and a lot of different types of places for people to live. People have different tastes, but it can be a little bit of a challenge for us when we're trying to determine what the context classification should be and how we would draw these blocks. So I'm going to show you an example here of one that has a fairly sophisticated system of roadways inside, and then how those would actually connect. So we'd start off here again by looking at our 2,000 foot cordon. Go ahead and draw those in there. And then we will use that as the back end where necessary. That will be the back end of our block structure. So for instance, if we start here and draw along this Lake Worth Road, It just so happens there is actually a road right at the 2,000 foot mark, but I follow that along. Then I'm following my streets to get a block structure. So I come up here and turn. Okay, now this road goes off to the left, but it crosses my 2,000 foot cordon right there. So I'm going to use that as the back end of my block. I'll follow that around until I reach another street, and then I'll follow those streets back around and complete my block. So that red outline there is actually that would be considered one block for our purposes of context classification here. Use the same exercise for each of the other blocks, so you end up with some interesting shaped blocks, but we can calculate the perimeter of those and the area of those and count intersections within them, and that tells us what we need to know for calculating those block perimeters. So I hope that's been useful. That is the method that we use when calculating block perimeters and intersection density in locations where the block size and the block structure is not well defined.